College Algebra. Today we're going to do two videos. It's really just one set of notes, but because of our recording problems as time goes on, I'm going to split this one up. So first we're going to talk about solving equations that are in quadratic form. In the second video you'll get solving equations involving absolute value. Super easy. So let's talk about quadratic form and what that means before I actually solve any equations. We are used to seeing quadratics as ax squared plus bx plus c equals 0. What we haven't talked about is that quadratic form means that this power, which is 1, is actually half of this power, which is 2. So if you look at these equations down here, my power here is 2, that's half of 4. That means that this is in quadratic form. When it's in quadratic form, I can treat it almost like it's a quadratic. So when we look at this, if this equation were x squared minus 5x plus 6 equals 0, we would know exactly what to do. We would find two numbers that multiply to be 6 and add to be negative 5, and we would say x minus 3 times x minus 2 equals 0. Well, have you ever noticed that the variable that's sitting here and here is the same as the variable that is right there? Well, there is a reason for that. That's because this is what I would multiply x times x to get x squared. Well, when we want to factor this guy in that same way, we still want to find two numbers that multiply to be 6 and add to be negative 5, but instead of just writing x in the parentheses, I'm going to use x squared. So two numbers that multiply to be 6 and add to be negative 5 are negative 3 and negative 2. So we're going to say x squared minus 2, x squared minus 3 equals 0. Now I can try to factor these further. They are not differences of squares. So what I'm going to have to do is set them each equal to 0 and use the square root method. So here, plus 2, and I get x squared equals 2. Square root, I get x equals, and don't forget your plus or minus, square root of 2. If I bring this one over here, x squared equals, if I add 3 on both sides, I get 3. Square root both sides, x equals plus or minus the square root of 3. So I have two solutions, or four solutions technically. X equals plus or minus the square root of 2, or x equals plus or minus the square root of 3. Okay, let's apply this idea again. To tell if it's in quadratic form, I need to check to see if this exponent is half of this exponent. Well, 1/3 is half of 2/3, so I can treat this like it's a quadratic. Some find it easier to come over here, write this as a quadratic, and then factor it here, and then come back and bring it over here and write it with the appropriate variable. So we're going to try it this way on this one. Mainly because we have to morph this. 3 times negative 4 is negative 12. What are two numbers that multiply to be negative 12 and add to be negative 11? So we would do negative 12x and 1x, or just x. And then we have factor by grouping. 3x times x minus 4 plus 1 times x minus 4. And then I get 3x plus 1 equals 0. And x minus 4 equals 0. Well, I'm going to stop there because really it's not x, it is x to the 1/3. So I'm going to come back over here and write it 3x to the 1/3 plus 1 equals 0, and x to the 1/3 minus 4 equals 0. I'm going to rewrite this by subtracting 1, dividing by 3, and then x to the 1/3 equals negative 1/3. Well, this is the same thing as the cube root of x. And we learned how to fix that, or get rid of that, by cubing both sides. So I get x equals negative 1 over 27. Okay. Doing the same thing here, adding 4, x to the 1/3 equals 4. I'm going to cube both sides because it's the cube root. So we get x equals 64. So these are my two answers. Okay, if going back and forth was really confusing, I'm going to actually erase this and show you a different way to think about it. I'm going to go back and do it without factoring it separately. Okay. So think about it like this. I'm going to go ahead and do the morphing. 3 times negative 4 is negative 12. So it's going to be 3x to the 2/3 minus 12x to the 1/3 plus x to the 1/3 minus 4. Now I'm going to factor by grouping. When we learn to take out GCFs early on, we always look at taking out the x with the lowest power. So 3 and 12 have a greatest common factor of 3, and the lower power between 1/3 and 2/3 is 1/3. Okay? To get what goes inside this parenthesis, I'm going to divide both of these things by my greatest common factor, 3x to the 1/3. Okay? If I do that, the 3's cancel, and then I would subtract the powers. 2/3 minus 1/3 is x to the 1/3. Minus 12 divided by 3 is 4. X to the 1/3 over x to the 1/3 just completely cancels out. There's my parenthesis. And this one, if you notice, this matches this, so I need to just take a plus 1 out. That leaves me with x to the 1/3 minus 4. And we get the same factors that we got in the other method I showed you. If you don't like the other method and you like this one, ignore it. And vice versa. So, now that I've got these two pieces, I'm going to set each of them equal to 0. I'm going to show this one more time. I'm going to subtract 1, divide by 3, and I get x to the 1/3 equals negative 1/3. And remember, cube root of x equals negative 1/3. Cube and cube, I get x equals negative 1 over 27. Okay. Over here, I'm going to add 4, x to the 1/3 equals 4. Cube root of x equals 4. Cube it. X equals 64. So there's my second answer. So negative 1/27 and 64. Okay. Let's try this one. Ooh, negative powers. That looks scary. But is this half of that? Absolutely. Also quadratic. This one's nice because I don't have a coefficient, so I can use that shortcut method. Two numbers that multiply to be negative 6 and add to be negative 1 are negative 3 and positive 2. So I know it's going to be minus 3 plus 2. This term, the half term, is the one that goes in the parentheses every time. That's not even the weird part. Here's the weird part. I'm going to set each of them equal to 0. I'm going to add 3. I get x to the negative 1 equals 3. X to the negative 1. What does that mean? That means reciprocal. I can say that's 1 over x equals 3. Well, that isn't x equals. So if I take reciprocals of the both sides at the same time, the reciprocal of 1 over x is x, and the reciprocal of 3 is 1/3, I can get what x equals. Same thing here. If I subtract 2, x to the negative 1 equals negative 2. 1 over x equals negative 2. Let's reciprocal both sides. I get negative 1/2. Another way to think about this. Let's say I'm at this point. I've got x to the negative 1 equals 3, and x to the negative 1 equals negative 2. The next thing I can do is take both sides to the negative 1 power. What that does is it undoes the negative 1 here. If you think about it, negative 1 times negative 1 is positive 1, which leaves us with just x. And this says to reciprocal 3, 1/3. Same thing here. X equals 2 to the negative 2 to the negative 1 is negative 1/2. So we get the same answers. Lots of different ways to think about this, even more than I'm going to show you. But that's it for things that are in quadratic form. I'm going to stop this video and I'm going to record the next one in a moment, and that's where you'll get your bad joke of the day. I know you can't wait.